So let us understand the formation of the methane molecule. Now, using Lewis or electron dots symbols or structures, methane has a formula CH4. In the formula of methane, there is one atom of carbon and there are four atoms of hydrogen. Now, to begin with, we first need to know what is the number of valence electrons present in each of them before we show the bonding between the two atoms. Now, first of all, you need to understand that this particular molecule has a covalent bonding, and covalent bonding is a bond formed between nonmetals, and nonmetals always share electrons between each other. Now, since carbon and hydrogen both are nonmetals, therefore they both form a bond between each other, which is known as a covalent bond. Now, in the first place, why do they form a bond? To understand that, let us first see what is the electronic configuration for carbon. Carbon has an atomic number 6 and its electronic configuration is 2, 4. That is, it has 4 electrons in its valence shell, or the outermost shell has 4 electrons. On the other hand, hydrogen has an atomic number 1. Its electronic configuration is also 1 and it has 1 valence electron. That is, in its outermost shell there is only 1 electron. Now if we look very closely, both the atoms, carbon as well as hydrogen, both are unstable. Since both of them are not following any of the rules of stability, carbon atom does not follow the octet rule, hydrogen atom does not follow the duplet rule. So, in order to become stable, they can easily form a bond with each other, and that is what actually leads to the formation of methane molecule. That is the formation of CH4. Now, it is very important for you all to note that why is this particular compound being formed and how it is being formed. The reason behind it being formed is that both are unstable atoms, and how it is formed is by first checking which out of the two atoms is going to be the central atom. Now, if we look closely, carbon atom requires 4 more electrons to become stable. Since it has 4 electrons in its valence shell, it requires 4 more electrons to become stable. Hydrogen, on the other hand, requires only 1 electron to become stable. So, in order to decide the central atom, the atom which requires more number of electrons is decided as the central atom. That is the atom which will be shown in the center. Since we can clearly see that the formula of methane is CH4, so it's very clear that the formula would have 1 carbon and 4 hydrogens. So how are we going to show the bonding? By first checking which is going to be the atom in the center. So now it is very clear that carbon is going to be in the center since it requires 4 more electrons to become stable. Now this can clearly be shown here. Now carbon atom is the central atom and it requires 4 more electrons to become stable. Now there is a very simple concept here for you to understand, that it is never going to form a bond with only and only one hydrogen atom. That means it's not possible, it's not going to form a bond here with any of these hydrogen atoms here or any hydrogen atom here. If you were to just hide the other hydrogen atoms and just see. Now if carbon was to form a bond with only one hydrogen atom, now since first of all you need to know that hydrogen can provide only one electron to carbon atom. So one hydrogen can provide only one electron to carbon atom. But carbon atom requires total of 4 electrons to become stable. So if you look at the structure, carbon atom is still short of, it was short of 4 electrons earlier, now it is still short of 3 more electrons. Therefore, with one hydrogen atom, it can never form a bond. That is why there is no such compound with the formula CH. Now let us see if it forms a bond with 2 hydrogen atoms probably. So if it is, suppose they are forming a bond with 2 hydrogen atoms, carbon atom will have 1 more electron here from one hydrogen atom, 1 more electron here with 1 more hydrogen atom. That means it is now having a total of 6 valence electrons, but it is still short of 2 more electrons. So this again makes it very clear that there cannot be a compound with the formula CH2. That is how no such compound CH or CH2 is ever possible. So let's see what happens if it forms a bond with, say, 3 hydrogen atoms. So suppose it's forming a bond with 3 hydrogen atoms. This is again not a possibility since still carbon is short of 1 more electron. It has 1, 2, 3, 4, 5, 6, and 7. 7 valence electrons, but is still short of 1 more electron. Therefore, any compound with the formula CH3 is also not a possibility. Therefore, carbon forms a bond with 4 hydrogen atoms. So it gets 1 electron from this hydrogen atom, 1 electron from this hydrogen atom, 1 electron from this hydrogen, and 1 electron from this hydrogen atom. So in turn, it is easily able to complete its octet. And each of the hydrogen atoms gets 2 electrons each, and in turn complete its duplet. Now this is shown with the help of the next structure here. As we clearly see here, if we draw circles just to see the completion of duplet by each of the hydrogen atoms. So I've just missed out one circle here for this pair of hydrogen atoms. So if we just draw a circle here just to show that yes, this hydrogen atom is also completing its duplet with 2 electrons here. This hydrogen atom is completing its duplet with 2 electrons here. This hydrogen atom is completing its duplet with 2 electrons here, and this hydrogen atom also has 2 electrons, so it is also completing its duplet. And in turn, carbon atom has 1, 2, 3, 4, 5, 6, 7, 8. It is also completing its octet with 8 electrons. Now if we see here very clearly, carbon atom has formed a bond with 4 different hydrogen atoms, and 1 pair of electrons has been shared between each of the hydrogen atoms with carbon. So it has formed 1 single bond here, 1 single bond here, 1 single bond here, and 1 single bond here. That means 4 pair of electrons have been shared separately between carbon and hydrogen, and these shared pairs are shown with the help of lines. These lines actually represent a bond. A bond is always represented with the help of a line. This is just a pair of electrons being shared, and this is the bond, and this bond itself represents one single line itself represents that 1 pair of electrons has been shared. So it's very clear that there are 4 single covalent bonds formed between carbon and hydrogen. And since there was only 1 carbon atom involved in this bond formation and there were 4 hydrogen atoms involved, that is how we get the formula of methane as CH4. So therefore, in total there are 4 single covalent bonds in the formula of methane. We can understand this with the help of this model also, as you all can see in front of you. In the center, this is the symbol for carbon, and these are the valence electrons of carbon in black. And these are the 4 hydrogen atoms forming a bond with the carbon atom, and these white ones represent the electrons of each of the hydrogen atoms. So carbon is forming a bond here between with the hydrogen atom here. It is forming a bond here with this hydrogen atom. It is forming a bond here with this hydrogen atom, and forming a bond here with this hydrogen atom. So here 1 pair of electrons being shared, a second pair of electrons being shared, a third pair of electrons being shared, and a 4th pair of electrons being shared. So very clearly it can also be shown like this here. This is another model. This was a model shown in a separate way, and this is a model showing pair of electrons being shared, and this is the model showing a bond formed between carbon and hydrogen. So this green clay in the center is representing carbon, and these orange clays are representing hydrogen atoms. So here there's 1 pair of electrons, so this is 1 bond, second pair, second bond, third bond, and 4th bond. So total there are 4 single covalent bonds formed between carbon and each of the hydrogen atoms. So this is what is the formula for methane, and I hope you all have understood with the help of these models and the explanation given here.